Before we move on to radical equations, let's do one more example with a polynomial equation. So here we have a polynomial on the left equals a polynomial on the right, and we'll use the recipe that we described in the earlier video, where we want to get 0 on one side, and we want everything else, the big polynomial, on the other, and the exponents should be written in descending order. So it looks like this should be x cubed plus 2x squared. I'm going to subtract 4x from both sides, and I'm also going to subtract 8 from both sides. And that gives me 0 on the right-hand side. So all I did is subtract the 4x from both sides, and I subtracted 8 from both sides. Now, maybe you remember how to factor this. We haven't done any factoring where we had an x cubed. But this is one you might remember from a previous class, where we're going to use something called factoring by grouping. I'm going to factor these two together, and I'm going to factor these two together. Now I want you to remind you that this does not always work. It will work for this because I know, here's a little trick why I know it's going to work. I look at the ratio. You could think of a ratio or a fraction. This coefficient is a 1, and this coefficient is a 2. 1 over 2. Well, this coefficient is negative 4, and this coefficient is negative 8. What is negative 4 over negative 8? It's the same as 1 over 2. So when that happens, when you could say the ratio of this to this is the same as this one to this one, you know that factoring by grouping is going to work. So let's see, what can we do? We're just going to factor out the greatest common factor, which would be an x squared. And then we would get an x plus 2, the remaining part inside the parentheses. And you can distribute this to make sure. X squared times x is x cubed. X squared times positive 2 is 2x squared. Now, what am I going to do? Sometimes I get confused on whether I put a minus or plus here. So if I get it wrong, it'll be the other direction. I think it's going to be a minus, though. And I'm going to pull out a 4. And again, this is going to be x plus 2. That's what we were hoping for. And let's verify that. Negative 4x, negative 4 times 2 is negative 8. And because these are the same, our factoring by grouping is successful. This is a factor now. This is a factor in the first term, and it's a factor in the second term. So I'm going to pull out that factor. And what am I left with? I'm left with this and this. X squared minus 4. I'll put that in parentheses here. Just like that. So all I did is pull out the factor of x plus 2 and x plus 2, leaving me with x squared minus 4 to go in the parentheses. X squared minus 4. And then I'm not quite done. That's a difference of two perfect squares. So we will have x plus 2. Let's see, this would be x plus 2, x minus 2. Equaling 0. So we'll now use the zero factor property to finish up. Well, this one says that x is a negative 2. This one says x is a negative 2. I don't need to repeat it. This one says x is plus 2. So we'll learn about this a little bit later. But in general, you can say that a degree 3 polynomial is going to have 3 roots. It could not possibly have more than 3. It could have less than 3, and all that means is it has 3 roots, but 2 of them are identical in this case. So we could have said we have negative 2, and 2, but we don't generally do that. These are the 2 values that when you plug them in will make this equation work. Negative 2 and 2. Okay, that's the last of the polynomial equations. Now let's move on to radical equations. A radical equation is an equation that has a variable underneath a radical. Very simple. So before I do a recipe, I'm going to do some examples first, and then we'll write up the recipe. And let's see if it's a little bit intuitive on how we can solve these. How would we solve this nice simple radical? radical equation. Radical x is equal to 7. Well, what do I have to do to a radical x, radical x, to turn it into just x? How do I get rid of the radical? Remember what a radical is. It's the second root. We don't generally write the 2 there, and when it is empty like this, we know it's the square root or the second root. But the way we get rid of it is raise both sides to the 2 power, second power. And you'll notice that the second root or the square root and a square or a second power, they cancel each other out. That's like saying the square root of take the square root of 100 and square it, and you get 100. So this is going to be x equals 49. So it's very simple. When you have a very simple one like this, you square both sides and you get the answer, 49. Radical 49 is equal to 7. Here we have a cube root. What do you think we have to do to both sides when we have the cube root or the third root of w plus 2 equaling 2? Well, to get rid of a cube root, you have to cube it. So we've got a third root here, and we're going to raise the whole thing, both sides, to the third power. And the third root and the third power cancel each other out. Just as a quick example, if you took the number 8 and you took the cube root and then you cube it, you're going to get 8, because the cube root of 8 is 2. 2 times 2 times 2 is 8. And then when you cube 2, you get 8, exactly what you started with. Well, what was under the radical here? Cube root of 8 cubed is 8. So in this case, what would we get? This just gets rid of the radical, so we still have a w plus 2 equals 8. And that would just mean subtracting 2 gives w equals 6. All right, and let's do one more fairly simple one before we write the recipe down. Let's solve this. Well, the nice thing about it is that there's a radical all by itself on one side. So to get rid of it, we just square both sides. That's all we have to do. So radical 3x plus 1 equals 4. Let's square both sides and see what happens. Again, this radical just gets, when you square it, the radical just goes away. So you end up with just 3x plus 1 on the left, and 4 squared is 4 times 4, or 16, on the right. Let's subtract 1 from both sides. 3x equals 15. So from 3x equals 15, we divide both sides by 3 and get x equals 5. Let's go back and plug it in just to make sure it's right. X is 5. 3 times 5 is 15, plus 1 gives you 16. 16 under a radical is equal to 4. Now, the recipe we're going to do is in the next video, but I do want to make sure you're aware of something. As you've seen, I don't always go in and plug in the answers to make sure they're correct, but anytime you square both sides of an equation, you are required to verify the solutions, because you may have made absolutely no mistakes, but they may not all work. So, and the ones that don't work, just this is the definition, you call them extraneous solutions. I don't even like that term because they are not solutions. You do perfect arithmetic, they come out as solutions, but when you plug them in, you find out that they really are not solutions. And this is a simple example, not using radicals, that shows why. Here's x equals 5, a simple equation. The solution set to this is 5. The only number that satisfies that is 5. What happens if you square both sides? you get x squared equals 25. Well, what's the solution to x squared equals 25? If you use the square root property, you get this, x equals plus or minus 5. So you see what happened? The solution over here is just x equals 5. If you square both sides, we got an extra solution, the negative 5, that does not work in the original solution. So, if you ever square both sides of an equation, the solution that you get, you need to plug in, if it's one number or two numbers, you need to plug all of them in to the original equation to see if it really works.